Hi, welcome to the Invention Studio. My name is Lauren Murphy, and today I'm going to show you how to use the Waterjet. The Waterjet cutter uses a stream of highly pressurized water and abrasive garnet, which gets blasted out through this very small opening in the nozzle. The garnet that I mentioned is pulled from this hopper through this tube and is mixed in with the water to help with cutting. This Waterjet can cut through almost any material, including metal, plastic, you name it. Here's an example part that we've cut out. See, this is a piece of steel. You can cut out any shape, any 2D profile that you'd want. It makes it much easier than any other method. So before we get started, here are some basic safety tips. Over here on our cart are our control buttons. We have a blue pause button, a red stop button, and most important is the red emergency stop button. If anything ever looks like it's going wrong with your cut, hit this button and it will stop everything immediately. When using the Waterjet, it's important that you always wear safety glasses. This protects your eyes from anything that could go wrong. And also, when the Waterjet is running, never put your hands inside the tank. It is very high pressure water and you don't want it anywhere near you. Before you begin, it is important to turn on the Waterjet in the correct order. Each step is labeled with a number. You must follow these numbers or else it can damage the equipment. When starting up the Waterjet, the first thing you must do is turn on the breaker. So remove the lock and switch it on. Next, go behind the Waterjet and turn the air valve counterclockwise to the 6 o'clock position. Next, turn the water valve counterclockwise to the 9 o'clock position. Next, turn this red switch clockwise to the on position. Once it's turned on, you can hear the motor running in the background. Next, turn this yellow lever counterclockwise to the 7 o'clock position. This allows cool water to run through the machine. Let this run for about 30 seconds, and then let's turn it off by turning it clockwise back to the 9 o'clock position. Next, turn this red switch clockwise to the 12 o'clock position. When the pump first turns on, give it a few seconds to start up. Next, turn this red switch on the front of the Waterjet clockwise to the 12 o'clock position. And finally, go to the pump here and press the reset button. Next, you must import your part file into our software. You must have this part file on a flash drive as this computer is not internet connected. When you plug in your flash drive, navigate to the .dxf file that you have saved and double-click on it. This will open up a program called Layout. And as you can see, here are the lines that were in my DXF file. First thing when you import a file is to click Clean, as this removes any issues with the drawing. So leave all the settings as they are, and click also Remove Unnecessary Dots. There we go, so it's clean. Next, you need to right-click on Quality at the bottom of the screen and select All, and then click Quality 3. Quality is a scale of 1 to 5, with 1 being the roughest cut and 5 being the cleanest cut. For most purposes, 3 is sufficient. So I'll close out of this dialog box. And now right-click on Lead I/O on the left side of the screen and click Auto Path Advanced and Configure. And this adds what are called traverse lines and lead-ins. Traverse lines are where the nozzle moves without cutting, and lead-ins are where it starts its cut. So I'll check that my path is good. I want my part to start from the bottom left corner, so I'm going to go to Path Direction Settings and set the bottom left corner. And so this is a good starting position for the cut. And when I'm finished, I'll hit Go, and see this automatically adds in my traverse lines and my lead-ins. For a small part, which means a part that is narrower than 5 inches, you'll need to add what's called a tab. If your part is very small, you'll need to add what's called a tab. A tab is a small connection to the rest of the material so your part doesn't fall into the tank. An example of a part that would need a tab is this small one here. This would almost certainly get lost. So in order to add a tab, right-click on Lead I/O, go down to Create Tab, and this will give you options for adding your tab. So find any place on this material and just simply click to add it. Some spots are better than others, so when the software doesn't show red lines, that's a good place. Now, one thing to consider when adding a tab is that you must grind it off later. You can grind it or sand it, so you must be able to get to it. So keep that in mind if you have an unusually shaped part. So on this particular part, the G and the T, as well as these 2 holes, will be cut through completely, which means they'll fall through into the tank, and that is normal. Holes are expected to fall through, and they basically end up as scrap. So, next, right-click on Path, and go to Automatically Generate. You'll need to pick your starting point that we decided earlier. So I'll go down to the bottom left corner and click on this edge here. Click it. Now, this shows the path that the nozzle is going to take as it goes through your part. One thing to consider is that this red line here, this red area, represents the offset of the jet. So the jet is 0.021 inches wide, and so that means that it needs to be spaced over a little bit in order to get the right dimensions. When you look at this path, you want to make sure that holes are cut on the inside so that your hole is the correct dimension, and that the exterior line here on this part is cut on the outside. This will make sure that all of your parts are the correct dimensions. So after you've checked that and made sure that everything is correct, go to Save, and that saves your path. So right-click on Path again, and go to Open ORD Path and Make. For this demonstration, I will be using this sheet of aluminum. So on this software, you'll need to input your material settings into this software. So you can click this drop down and pick the material, which in this case, it is aluminum 2024. So I'll click that. I also need to tell it the thickness. So in this case, the thickness is, this sheet is 0.12 inches thick. So here, I'll enter in my material thickness and leave everything else the same. Next, I'll hit OK. And this opens up a program called Make. So next, we need to load our cutting piece into the Waterjet. So to do that, I will pull down this shield, lift it out, take my piece, and set it into the tank on top of it. So set it in there, and I will line it up with this L-shaped piece here. So next, I need to use weights and clamps or any combination in order to secure it. When you secure a part, you need to make sure it does not wiggle at all. If it wiggles, it could possibly flip up and damage the nozzle. So this is one of the clamps I can use. It has 2 bolts. One bolt goes in the slot here, and then you screw that into one of the holes on this L-shaped piece. So I'll screw that in. Actually, I will use this one. I'll screw that in here. There are several holes on this L-shaped piece, so you have several different places to choose from. So I'll screw that in, and then I'll push it out here so it's touching the metal, and then I'll take an Allen wrench and tighten these bolts down even further. Let's tighten this one. That's one part held down. A good way to check if your part wiggles is to just take your fingers and tap on it. There's still a little bit of wiggling in the middle, so next I'll use this weight, big weight, and I'll set it right here. And now my part doesn't wiggle at all. Another way to secure your part is to use one of these clamps. So you can bring it in, fit it almost all the way, and then squeeze it until it's tight. You see that the garnet hopper is low before you start your job. Use this pitcher and put garnet into it. Flip up the top of the hopper and pour it in. Make sure when you're finished putting garnet into the hopper, always keep this pitcher with this side up. If water gets into the pitcher, it can cause the garnet to clump together and clog in the machine. You can use the arrow keys to move the nozzle around on the working area. So I can use the down arrow, the up arrow, left and right. And I can use this to bring the nozzle over to where I want to start. Using the 7 and 1 keys on the numpad here, you can raise and lower the nozzle. You use 1 to lower it and 7 to raise it. So I'll use the 1 key to bring the nozzle close to my part. You want to leave about ½ an inch of space though. Don't get it too close at first. So if you look here at our starting point, you'll see these crosshairs. So this corresponds to where the Waterjet will start your path. And we'll need to set what's called a user home and the path start. So to do this, I'll navigate the nozzle using the arrow keys to where I want to start. The best starting position is one where the path will not interfere with any weights or the L-shaped piece or any already cut out parts. You want to make sure that the nozzle does not run into any high parts because it can break. So the right position to start your path is one where the nozzle will not interfere with any clamps, this L-shaped piece, or any weights. Because these are higher than your cutting surface, there's a risk that the nozzle will break. You also want to not interfere with any existing cut out pieces, then your part will not be the right shape at all. So using the arrow keys, I'll move the nozzle over to a good starting position. I'll move it down just a little bit. You get a good feel of where to start. And that looks good. It's away from other cutout pieces. It won't hit any obstacles. That's a good place to start. Once you've found a good starting position, you'll click on the zeros here for user home. Click that. It'll ask you if you want to zero the home. Click yes. Do the same thing for path start. Hit the zeros and reset it. And that is how you set your X and Y home. So the next step is to set the Z height, which is the height above the top of your material. So you want to get it very close, but not touching your piece. And in order to get that distance, we have a tool you can use to measure the distance between the nozzle and the piece. So in order to get the distance, I'll use my finger gently resting on the side of the nozzle, not underneath, on the side, and I'll lower the nozzle using the 1 key until my finger is touching it. You want to be about 1 finger width above. There we go. So that's close. And now I'll use this tool and I'll use the page up and page down keys on the keyboard to do fine control of the height. So I'll start lowering it using page down and I'll sweep the measuring tool under the nozzle. You want to make sure that there's no resistance. So I'll continue lowering it and sweeping and checking. See, at this point, it can't go any further. So I'll need to use page up to lift it until it sweeps with no resistance. If you ever need to check how far it is, you can hold this underneath and pop it up a little bit. This gives you kind of a rough estimate of how far you are. So once the nozzle is at the correct Z height, you'll go to the Z height dialog box and click the zeros. And this will reset the counter so that this is your starting height. Now, it's good practice to check multiple points of your part, particularly if it's a large part. So in this case, I want to navigate the nozzle over to this side here and check the Z height over there too, to make sure that there's no chance it's going to collide. So a quick way to navigate from different parts of the path is right-click on Begin Machining and click Go to Spot on Path. And this will send the nozzle directly to any point on these lines. So the next point I'll check will be this top right corner. So I'll click this. It will move directly to that spot without raising the Z-axis. So make sure that there are no weights or clamps or anything else in the way that could damage the nozzle. When I hit OK, you can see that it moves directly to that corner. So as you can see on the computer, a dialog box called Path Control has opened up. Don't hit any other buttons yet, just goes directly to close. And we're back to where we started. So next, I'm going to remeasure the Z height like I did the first time using the exact same process. And I'll check if it's higher or lower. So to check it, I'll raise it up briefly, put my finger, lower it as if I just started over. And I'll take the tool and use page down, a little resistance, page up. There we go. So now that I found the 0 point of the second part of the path, I check the Z height, and the counter is telling me that this is 0.0055 inches below my previously set 0 point, which means that I need to take the higher of the 2 points in order to prevent a collision. So in that case, I'm not going to re-zero it. I'm going to leave it as is. If this number were higher, I would re-zero it and set it to this new number. So I'll put the nozzle back at the previously set height by clicking this green arrow, which sends it to what the 0 height is. Click OK, and that raises it up back to the original height. So next, we need to make sure that the nozzle is back at a home position. So click Go Home for either of these because they're set to the same position. I do not want to raise the Z-axis, but if you had any weights or anything in the way, you would want to instruct it to raise it and click Yes. But in this case, I will click No. It traverses back to the original spot. When you're ready to begin your cut, flip the yellow cup down. This cup prevents any splashing that might occur while the water jet is cutting. You keeps the water contained so it doesn't get all throughout the room. You'll also need to replace the shields, set them back on their ledge. And you are ready to go. You'll also want to move the computer cart well away from the water jet to make sure that no water hits the computer. Before you cut your part, it's a good idea to run what's called a dry run. Before you begin your dry run, raise the Z height to roughly 2 inches. This will make sure that the nozzle is clear of any possible obstacles. To do this, right-click on Begin Machining and click Begin Default. This is that same dialog box from earlier. And be careful, because if you click this red button, it will start cutting. To do a dry run, right-click on the red button and click Dry Run at full rapid traverse speed. With the nozzle above the surface of the water, right-click on the red button that says Start and click Dry Run at full rapid traverse speed. The nozzle will then go through the path as if it was cutting, but it will not actually cut. Use this time to make sure that it will not interfere with any clamps, any weights, or any possible other obstacles. When the dry run is finished, you'll need to send the nozzle back to the home position. So click Go Home, No. And then you'll need to set the Z height back to 0. So click the green arrow, move it to the 0 point, hit OK. And then it lowers back to its original position. And now you are ready to begin machining. So once all of your counters are zeroed, click Begin Machining, and then click Start. Now the Waterjet will begin cutting. Keep your hand near the pause button in case anything goes wrong. Now that your cut is finished, hit Close on the path control box. Raise the Z height so that the nozzle is clear of any obstacles, and move it using the arrow keys so that it is out of the way of you lifting your part out of the water. Next, take down the shields. Remove your weight. Use the Allen wrench to undo the clamp. And release the other clamp. You can now take your sheet and pull it out of the water. Let the water run off. Set it up to the side briefly. It's a good idea to use the hose over here and spray the garnet off of your piece. Careful not to spray too much else though. Now since your part is still attached to the material because of the tab, you'll have to wiggle it back and forth until it breaks. It leaves a little stub on the material, but you can sand it off or grind it off depending on what material you've used. When you're finished with all the jobs you want to cut on the Waterjet, go up to History and Counters and Timers, and we need you to record the total hours on pump in our log. So you'll use the hours here. In this case, it's 319.968. You'll want to record that number in our logbook over here with your name, email, and purpose. So next, close everything, close make, close layout, and you can remove your flash drive. When you're completely finished using the Waterjet, do the opposite of what you did to start it. So turn off this switch, turn off this switch, go back here, and turn the motor to off. It'll quiet down. Next, turn off the water and the air. And finally, turn the breaker off and lock it back. And remember, this order is important because if it's not done in the correct order, it can damage the equipment. Thank you for watching this video. Hope to see you in the studio soon.